Example 4. Write an explicit rule for the recursive rule. So specifically here, we're translating between recursive and explicit. Usually the first thing I like to do is make a table so that we get an idea of what's actually going on here. So in our table, 1, 2, 3, 4, 5, that should probably give us a pretty good idea of what's going on. And then let's look at what we're given. So the first thing we're given is a sub 1. A sub 1 is the first number in your pattern, negative 45. Then we're given a recursive formula, and in the recursive formula it says take whatever number you're trying to find, take the one before it, add 20. That's the key, add 20. So if I'm trying to add 20, I know that D is 20, which is a common difference, which means this is arithmetic, which essentially means linear. Now, if I kind of look at my table and I want to add 20, so add 20, negative 45 plus 20, negative 25, add 20, negative 5. Add 20, you get 15, add 20, 35. Now, we're adding 20, that's arithmetic, which means it's linear. When I do linear, I always kind of revert back to y equals mx plus b. If we're doing that, we have y equals, keep in mind m is your slope. Well, your slope is add 20, so 20x plus b. Well, b is your y-intercept, and keep in mind your y-intercept is when your x value is 0. So we have to add that on. Now, if we're adding 20 this way, that means we're subtracting 20 the other way, so negative 65. Y-intercept is negative 65, so I'm going to get rid of the plus. I'm going to put negative 65, and this is your explicit formula. Now, the reason we like this formula so much is because if I want, let's say, the 100th number in the pattern, you can just substitute 100 here and it'll tell you what it is. Versus with this formula, the recursive, if you want the 100th number in the pattern, you literally have to sit here and add 20, add 20, add 20, add 20 until you get out to 100. That just takes way too long. Letter B. Okay, once again, let's make a table and kind of see what's going on here. 1, 2, 3, 4, 5. And they told us here that the first number in the pattern is 13. Now, I look over here at my recursive rule. My recursive rule says we're taking negative 3 times the number before it. But the key here is negative 3 times, which means your common ratio is negative 3. If you have a common ratio, we know this is geometric, which essentially means this is exponential. So I'm going to come down here. I'm going to multiply by negative 3. So 13 times negative 3, negative 39. Times negative 3 is 117. Times negative 3, negative 351. And we'll do it again, is 1053. Now, if we're dealing with geometric or exponential, this is the formula a sub n equals a sub 1 times r to the n minus 1. So a sub n, remember, is just like your y. That's like y equals a sub 1, first number in the pattern, 13, times r, we're multiplying by negative 3, to the n minus 1. Keep in mind n is just like x, and there's your explicit formula.